Hi everyone, today we'll be presenting our major research project for Assessment 3. This presentation investigates the use of skyview factor across the urban canyons of Port Melbourne and aims to benefit urban densification and combat future climate issues such as global warming. In the worst case scenario, within the next 70 years, Melbourne sees itself to gain an annual average of up to 5 degrees, according to Climate Change Australia. This will lead to the adaptation of climates similar to those in more northern areas such as Dubbo and Griffith. With this, the urban sprawl within the greater region of Melbourne continues to grow. Information from the Australian Bureau of Statistics from 2001 to 2019 displays a growth in population moving outwards from the city. This is predicted to continue in future. The continuation of this activity forms both negative economic and environmental consequences. A reduce in housing affordability and higher emissions from increased need to transport across roads, to name a few. To combat this, we find densification within cities to be our best solution. However, existing local areas such as the Melbourne CBD struggle to show viable examples. The spaces between buildings, defined as urban canyons, trap long-wave radiation within them, which contributes to the phenomenon known as urban heat islands. For this project, we chose to investigate the use of skyview factor, which is the amount of sky seen at any one point within these canyons, as it forms an established parameter which can predict urban heat islands. The chosen site for our proposal is a residential block located in Port Melbourne on the corner of Knott and Bridge Street. This area is currently occupied by low-rise buildings, though looks to be favourable spots for future growth. The precedents for our proposal look back at more modernist approaches to these spaces with primary use of slender tower forms. Initial analyses use a base which occupies the entirety of the block at a height of 3 stories, creating a volume of 75,000 cubic meters. We use this as a basis of volume which we can then rescale and split up to visualize different effects on the surrounding canyons. From here we learnt that more slender forms were ideal. Next we tested various slopes, learning the higher our flattened face was, the better the skyview factor would be. We also tested various transformations of our slender tower, learning no real changes to skyview factor were made. Our favorable forms were then tested in a grid formation, revealing the benefits of vertical tapers. Here we have our rationalized optimal form, which was chosen based on the results of earlier analyses. We also looked at additional subtractions in the form, though found 3 primary issues, that being volume and GFA loss, the need for additional scaling to maintain volumes, which in turn negatively affected skyview factor, or plain unfeasible places. Our conclusion looks to utilize these tapered forms across our proposed area for both commercial and residential uses, allowing for densification while optimizing the skyview factor within the urban canyons. This will in turn adapt these areas to form more comfortable spaces for the users within for the future to come.